Search virtual labs. And as we scroll down under the title Broad Areas of Virtual Labs, we'll click on to Electronics and Communications. And here we're gonna choose Digital Applications Lab. So today I'll explain a real life application of logic gates, that is cockpit warning light control system, which is used in aircrafts. So let's see about the aim. So this system ensures that the pilot is alerted whenever the engine crosses unsafe conditions. It is mainly designed for special aircrafts, and let's move on to the theory. So the system uses three sensors. The first one is RPM sensor. So it gives output 0 only when speed is less than 5500 RPM. And we use pressure sensor output is equal to 0 only when pressure is less than 210 psi, that is pounds per square inch. So next is temperature sensor output is equal to 0 only when temperature is less than 2100 Fahrenheit. So RPM sensor means revolutions per minute. So it tells how many times the engine shaft spins in 1 minute, just like counting how many times a fan rotates. And next is pressure sensor. It measures the fuel or oil pressure inside the engine, just like checking blood pressure in our body. So it is measured in psi, which is pounds per square inch. It tells us how much force is applied on 1 square inch of an area. Next is temperature sensor. So it measures the engine heat, just like a thermometer checks our body temperature, and it is measured in Fahrenheit. And these sensors give digital signals. RPM sensor gives output 1 if it is greater than or equal to 5500, otherwise it gives 0. And pressure sensor gives output 1 if the value is greater than or equal to 210 psi, otherwise it is 0. Temperature sensor gives output 1 if temperature greater than or equal to 2100 Fahrenheit, otherwise it gives 0. And the concept of this logic, and the logic concept is the warning light turns on when temperature is high or either pressure is high or RPM is too low. So this is the logic expression from which the warning light is detected. And next we'll see about the procedure. So the NOT gate inverts the RPM signal, and the OR gate combines pressure and not RPM. AND gate checks the result with temperature and gives the final output, and drives the warning light and alarm in the cockpit. So next we'll move on to the simulation. So as the temperature is high, the warning light is turned on. When pressure and RPM is high, the warning light is still turned on. When temperature is low, the warning light is automatically turned off. Or when pressure is low, the warning light is automatically turned off. So that's it about our cockpit warning light control system. So stay tuned for further videos. Thank you.